Good morning, chemistry students. My name is Mr. Adam. This is chemistry. Today is the 17th of April. It is a Friday, and it is day 2. Happy Friday, everybody. We made it through week 3 of online learning. So I know this has been a lot different, and it's been going fast in some ways, and it's been going slow and kind of dragging on in some ways. But we're through our 3rd week of online learning. It means we have only about 7.5 weeks left school before we hit June, and before you know it, we'll be out of school and hopefully enjoying a little bit of summer weather, hopefully enjoying a couple things that are open and around and available for us to do in the summer. So, want to address a couple points today, a couple agenda items and things like that, and then talk a little bit about our lesson today, because our lesson today is a little bit different than yesterday's. It plays off of yesterday's, but it's important to kind of talk about the differences. So, first of all, today, I said yesterday we'd have live video meetings like we always do on Fridays. We're going to have those again by period. I'll send you out an email in case you don't get a chance to watch this video, and I'll send you an email and post on the Google Classroom what time those are going to be. So those will be, second period will start at 1:30, third period will start at 2 o'clock, fifth period will start at 2:30, and eighth period will start at 3 o'clock. Again, we'll go for as much time as we need to on those live meetings. We don't have to be there the whole time if we don't have a whole lot to say or a lot to contribute, but we'll chit-chat a little bit, talk about what's been going on in our lives, and maybe review a little bit of chemistry if we have some time. Okay, second thing is next week, we will have our Unit 2 Section 1 quiz. That will be next Wednesday. So, because obviously you've been doing this all online and you've been using the notes and the readings, I think the consensus among chemistry teachers is that will be open notebooks, so you can use resources for that as you're doing that. But we do want to take a second to review and take a second to review the way that we normally do, right? And have some fun and kind of bring everybody back in and bring everybody together. So next Tuesday, we'll be doing a live KAHOOT. I'm going to be making that KAHOOT over the weekend, and then we'll all do it together in one big class. Together, we'll do a live KAHOOT next Tuesday. Need you to tell me, if you're paying attention to this, what time would work for you. Is it better to do in the morning or in the afternoon? I'm thinking right now probably around 10 or 10:30 in the morning, so we can do that, and then you can have a chance to study your way after that, or get to your other classes after that. So we'll have that next Tuesday. Look forward to that, and I'll send out an email with more details on that. Okay, so on to this lesson, what we're doing today. Lesson 2.8, which is your last lesson in Unit 2, Section 1, is called Analyzing Ester Synthesis. So this is all about analyzing the lab that we did and talking about what actually happened in there. We know that we started with a putrid-smelling chemical and a medicinal alcohol-smelling chemical, right? And when we combined them, we made a sweet-smelling chemical. And that told us that there had to be something new there. We had to have a new chemical. But we know a few things. Number one, we know that the law of conservation of mass and matter says that whatever you start with, you must end with. Whatever pieces and atoms you start with, whatever elements, however many you have of them, you start with, you have to end with the same kinds of elements and the same number of them, right? Okay, so we know that's true. But we also know that atoms and elements like to rearrange themselves, like to rearrange each other, and that's how we create something new. We create a new molecule because it's different from the old molecules in how it's structured and how it's arranged and how it's shaped. Maybe the new molecule has more atoms and elements than the old two did because both of them contributed to make something new, right? You'll have the same amount that you started with and the same elements that you started with, just in a different form, just rearranged in different molecules. So let's talk about what we mean. In this lab, hopefully you read in the data in that completed lab what chemicals you had to start with, right? So you should realize that you had butyric acid in one of the experiments, and this was what we know as a carboxyl. And again, it's a carboxyl because you have HOCO combined together, right? A C double bonded to an O, single bonded to an O, which is connected to an H. Again, when you're looking for functional groups, you look for the O's, and then you see what they're connected to. And again, you see it's connected in this pattern, which makes it a carboxyl. We added this carboxyl to what we call an alcohol. In an alcohol, you only have one O, and it's connected to a C and an H. This is again what we call a hydroxyl group, and that makes this an alcohol. So when we combined these two molecules, they reacted together and they made something new. Now that means that everything that we start with here, all these elements, all 1, 2, 3, 4, 5, 6 carbons, and 1, 2, 3 oxygens, and however many hydrogens off the top of my head, I think there are probably 14. All of those elements still have to be present in our products. They still have to be present at the end of our reaction, but they're going to rearrange. So watch Miss Marnick's video for this one because it's pretty good. It goes into pretty good detail on how these things rearrange and how these chemicals might change. But when we have these two kinds of chemicals combined, what starts to happen is they start to rearrange and the bonds start to bond differently and the structures start to change. So what you start to see happening is that these bonds that exist here, some of them, certain ones, start to break. Okay? And they start to break at very specific points. Okay? This carboxyl over here, it actually starts to break right here. Right between that C and that OH group on the end, right? So it starts to break between the C and the OH. So this OH, it's out of here. It's going away, connecting with something new. These C's and this double bond and O are all sticking together. Over here on the alcohol, the bond starts to break between the O and the H. So these C's and this O are sticking together, they're staying together, but this H, it's out of there. It's going somewhere else. It's going to connect with something new. Now, these things aren't just going to all float around in space and then be broken down and just, exist as pieces and parts, but rather they're going to switch up and partner with some of the pieces that remain. So this piece and this piece here are going to partner up. And this piece here are going to partner up. And at the end, you're going to have the same atoms and elements, but you'll have different molecules. You have different molecules because they've rearranged into something new, right? Into something different looking. Okay, so if you have HO and H and they pair up, what does that make? Think about it for a second. Count your number of elements. You have H, H, O. That's 2 H's and 1 O. That's H2O. What the crap is H2O? Okay, let's see. It forms HOH or H2O. What is H2O? I hope you know by now that H2O is water. So one of the things, I can't find my mouth. One of the things that you're going to see in this reaction, oh, there you go, is that the H and the OH, that they break off together and then they combine to form water, right? So H and OH break off to form water. Okay, but we still have all this other stuff left, right? We have all these other pieces and parts left. So I'm going to erase water because we already accounted for that. We already saw what happened to the water. Now we have to figure out what happens to the rest of it. There you go. We have to figure out what happens to the rest of it. Well, you'll see here that you kind of have two jagged edges, two puzzle pieces that are going to fit together really nicely. So in your head, what you should see happening is that water kind of being sucked out of there, removed from there, and these two puzzle pieces kind of snap together and fit together. So what you're going to see is that these two puzzle pieces are going to combine. And this carboxyl and this alcohol, you're going to take the water out of it, and then you're going to combine them together. Okay? Puzzle pieces combine together to form this chemical here. So let's focus on this chemical here for a second. Okay? It has 4 C's in a row, and then a double bonded O, just like that carboxyl did over there. And then it's connected to another O, and then it has 2 C's connected to it, just like that alcohol did over here. I'll show you that again one more time. Right? 4 C's, whiteboards. 4 C's, double bonded to an O, and then O, single bonded to 2 C's. Same deal here. The only difference is this time they're all combined together in one big molecule. So let's look at this new molecule and see what it is. Okay? You see that you have 2 O's in this molecule, one double bonded, one single bonded, and you have a C double bonded to an O and an O, and then that O is connected to a C, not an H. So think about what Miss Marnick told you, right? We're going to look at this, highlight this real quick, and check out what the functional group is, right? Okay. What functional group looks like this? Has C, on to an O, on to a C, double bond to an O. Cocoa. Smells like cocoa. Must be sweet smelling. Must end in A to E. Must have 2 oxygens, and it must be a what? That's what they call an ester. Okay? So esters, you'll remember, are always the sweet, fruity smelling compounds. Why do we actually use esters? Why are esters important? Why do I care about this kind of stuff? Well, if you ever smell fake banana or fake raspberry or fake apple smell, maybe you go to, I don't know, Candle Shop or Bath and Body Works or something like the Candle Lab, and you smell these fake smelling, fruity, sweet smelling compounds. They're generally made of esters. So the scientists, the smell scientists or the chemists who had to figure out what that smell was like had to make a bunch of these different esters and synthesize them together, create them so that we could have these smells and experience these smells, right? It's kind of cool. Smell science is this deep, crazy field where you have to know a lot about the chemistry, a lot about your noses and smell receptors, how those work to get a certain smell to be the way it is. But anyways, I digress. What happens is you have your carboxyl and your alcohol combine. Take out the water and they combine together to make this new functional group. And this new functional group is an ester. So that's exactly what happened when we synthesized an ester. And Miss Marnick's video is going to walk you through a little bit how you could see the creation of a different kind of ester. If you started with a different carboxyl and a different alcohol, what ester would you get from that? So make sure to watch Miss Marnick's video today. Make sure to take that in before you take the assignment on Monday. I know you have a long weekend before that, but make sure you're prepared for that assignment on Monday. We'll have our KAHOOT on Tuesday, and then we'll have our quiz Wednesday. Then we'll be on to Unit 2, Section 2. Already done with one section in our first couple weeks of online learning. It's great. So, hopefully I see some of you today in the live meetings. I'm going to give you your share of the day and ask that you think about it a little bit, and we'll share it when we actually get into the meetings today. So, for the share of the day today, what is something awesome that a friend or family member has done for you or for the community? I know all you guys have the pleasure of living in the Mount Lebanon community. I don't get to see all the cool stuff that's been done around the community and for the community. But what's something awesome that a family member or a friend has done for you personally or for the community? I want you to recognize what someone in your life has done positively in this difficult time. Okay? So bring that today to our live meetings if you're going to be there, or share it to me somewhere or on the boards. But hopefully I see you all today. Hope you had a great week, and I will see you all next week if I don't see you today. Happy Friday, everybody. Let's get a 1, 2, 3. Clap on me.